Let's identify subsets, universal sets, empty sets, and set complements. Lots of excitement here. So first, let's talk some terminology. The universal set. This is everything, right? So the universal set contains all the elements of all the subsets that exist within that universal set. So it's just everything. A subset is a specific portion of the universal set. So we can break that universal set into, well, a lot of different subsets depending on the things. Now, if we have an empty set, that simply means we just have no elements. So there's just nothing in it, hence the name empty. And the complement of a set is all elements not in the set that we're talking about. So if we have set A, okay, then the complement, we would say, is A prime, or sometimes you see it as A with a little c. So these two mean everything not in A. So if you know A, then you just take everything else. Okay, all right. So what does that look like in terms of an image? So a lot of times we will put a universal set in a rectangle. So everything that exists inside the rectangle is the universal set. Then we would have subsets in little circles, right? So we would like say subset A. So if the circle is A, then everything outside of the circle would be A prime, or the complement of A, right? And you could have more than one, right? So we could have another circle, and this could be called B, right? That kind of thing. So it's not just one subset. We could have a bunch of subsets in here, but that's kind of the basic idea. So use this image to find A prime, and U. Okay, so first let's start with A. The set of A is everything inside the circle because this right here is A. So that would be 1, 3, and 4. Okay, A prime is everything not in A. So if we take out the circle, what do we have left? Well, we have left 6 and 7. U, the universal set, U is everything. So in this case, we have A and A prime that make up the universal set. So it would be 1, 3, 4, 6, and 7, right? Everything. All right, let's do one more. Consider U, the universal set, is the set of integers from 0 to 20 inclusive. That means 0 and 20 are part of this. That's what inclusive means. If A is the set of integers divisible by 3, what is A prime? Okay, so I find the easiest way to do this to say, well, if A is the set of integers divisible by 3, let's start there, right? So 3, 6, 9, 12, 15, 18. Whoop, that's my integers divisible by 3. So A prime is going to be everything else in the universal set that is not included in A. Starts at 0. 0, 1, 2, 3 is already taken there. 4, 5, there's 6, 7, 8, there's 9, 10, 11, there's 12, 13, 14, 15, 16, 17, there's 18, and then 19 and 20. So I think it's easier to start with the set and then work to the set complement. But if there's an easier way in your head to do it, that's totally fine. So that is kind of playing with subsets, universal sets, empty sets, and set complements.